In order for the lamps to be powered, they must each be connected to an output. Connect the red light bulb to output 1, the amber light bulb to output 2, and the green light bulb to output 3. Then use the wires to connect digital output line 0 to enable 1, digital output line 1 to enable 2, and digital output line 2 to enable 3, ensuring each circuit contains its own 10K resistor. The lights are now powered. To wire the switch, connect pin 3 of the switch to either of the ground connections on the pin header, and pin 1 to a row on the breadboard. In the same row, insert a resistor into one of the nodes. A wire will connect the junction of the 10K resistor and the switch to the digital output line 3 pin header. The resistor is also connected to either of the 5-volt outputs. Now the switch has also been properly wired.
We are now going to create the program for the traffic light using Labview. First, we need a while loop to encase the program in, which can be found in the Structures palette. Create a stop button in the front panel, then switch back to the block diagram and connect it to the loop condition. Inside the while loop, add a case structure and connect the case structure to the loop condition and stop button. In the true case, you're going to need a DAC assistant for the lights. From the Express palette, click Output and then DAC assistant. Then click Generate Signal, Line Output, and select port 0 and port 2. This will connect to the green light. Test the DAC assistant, and when finished, click OK and rename the DAC assistant to green light, so you know which function it is. With the green DAC assistant done, add a build array attached to a true Boolean constant, connecting the circuit to the DAC assistant. This provides a true constant for the lamp, using the build array to convert the signal into information which the DAC can process. By doing this, the green light will always be on if the loop condition is met.
Now, switch to the false case. In the false case, add another case structure. Create an enum constant, and then right-click it and select Edit Items. In the properties of the enum constant, create 4 values: green as value 0, weight as value 1, amber as value 2, and red as value 3. Each different value of enum constant will allow us to create 4 different functions that can be used in a series. Close the properties of the enum constant and wire the constant to the case structure. At this point, the enum is not really wired to the case structure. Wire from the tunnel to the case selector on the other side of the case structure terminal.
While wiring the enum to the terminal, a feedback node should have been created. If a feedback node has not been created, right-click the Initializer terminal and select Appearance tab, and click on Feedback Node to show it. Right-click on the Initializer terminal and select Create Constant. Automatically, green should be the default selection. This will force the green case to go first. To add all the cases necessary, right-click on the edge of the case structure and select Add Case for every value. This will add all the necessary cases automatically. You should have a green case, a weight case, a amber case, and a red case. Now we need to add the enum constants to each case. In the green case, set the weight enum. In the weight case, set the amber enum. In the amber case, set the red enum. And in the red case, set the green enum. This tells the structure where to go in the next case. We are going to need a DAC assistant for each light. Since we already made one for the green light, that means we only need amber and red. To do so, we follow the same process we did for the green light. While in the amber case, go to the Express palette, click Output and then DAC Assistant. Then, Generate Signal, Line Output, and select port 0 and line 1. Hit OK, and the amber light is now connected and should be renamed as such. Just as we did with the green light, add a build array attached to a true Boolean constant, connecting the circuit to the DAC assistant. Now, the amber light will turn on when the program reaches the amber case. Switch to the red case and follow the same process, the only difference being for the DAC assistant we select port 0, line 0. Switch back to the true case of the larger case structure and copy the original circuit for green. Switching back to the false case and selecting green, paste the structure. Now each light is functional. However, we're not finished. To ensure each light turns off as it switches to the next, we require a false constant connected to the prior light. We can do this by simply copying and pasting each light circuit into the following case and clicking on the true constant so that it changes to false. In the wait case, we paste the green light circuit with a true Boolean constant and an amber light circuit with a false constant.
Because the switch has to trigger the cycle to begin and the program starts with green, the green case is where we will program this. Within the green case, create a while loop, ensuring you have enough room to do so. We need to create a DAC assistant to monitor the position of the switch, so within that while loop, from the Express palette, select Input and DAC Assistant. Select the Acquire Signals option, Digital Input, and Line Input from the Digital options. Select Port 0, Line 3, and OK at the bottom of the dialog box to build the Input DAC Assistant. Rename the DAC Assistant to something that reminds you of the function, like switch. The DAC Assistant provides information in the form of an array, so we need to add an index array block to pull the data we want from the array of the two switches. The program is nearly complete. If you were to run it at this stage, it would work, but there will be no delays between each case. Starting from the green case, from the timing palette, select wait and create a constant of 10,000 milliseconds. In the wait case, put a wait of 6,000 milliseconds. In amber, 5,000 milliseconds, and in red, 15,000 milliseconds. The program should now be complete.